Pluto is a faraway, elusive, and less conspicuous planet that was once considered part of our solar system. However, recent groundbreaking statements from prominent astrophysicists like Neil deGrasse Tyson and Michio Kaku have brought Pluto back into public discussion. They have proposed that this icy planet might be heading toward a potential collision course with Neptune. But how can such a scenario be possible, and what would the consequences be of such a monumental event? Are we witnessing an unusual, unpredictable phenomenon, or is there something more to this impending cosmic disaster? Join us as we explore the possible outcomes of a Pluto-Neptune collision. Pluto, which was once classified as a planet but later redefined as a dwarf planet, continues to be a subject of fascination and study within the vast universe. Recent speculations from leading experts have suggested that Pluto's orbit is alarmingly close to Neptune's, prompting astrophysicists Neil deGrasse Tyson and Michio Kaku to warn of the possibility of a catastrophic encounter between these two celestial bodies, which could pose a significant risk to Earth. But how could such a collision even occur? Pluto's orbit around the Sun is unlike that of any other planet in our solar system. It takes a staggering 248 years to complete one full orbit. Since its discovery in 1930, Pluto hasn't even finished a single full revolution. However, the intrigue doesn't end there. Pluto's orbit is characterized by its distinctly elliptical shape, straying far from the nearly circular orbits of the major planets. What makes Pluto's orbit even more unusual is its tilt. Its orbit is inclined at an angle of 17 degrees to the plane of the solar system. This gives Pluto's path a far more erratic trajectory compared to the more orderly orbits of the other planets, adding complexity to its orbital dynamics. Perhaps one of the most fascinating aspects of Pluto's orbit is that it intersects with Neptune's. For roughly 20 years during each orbit, Pluto actually travels closer to the Sun than Neptune does, defying conventional expectations of their relative positions in the solar system. This raises the obvious question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational forces exerted by other planets. After Pluto's discovery, astronomers quickly set out to understand its strange orbital behavior. Unlike the other planets, whose orbits are relatively close to the solar plane, Pluto's orbit stands out because of its steep inclination and highly irregular shape. The puzzle deepened when it became clear that Pluto's orbit intersects Neptune's. Despite this, Pluto's orbit remains stable, demonstrating the intricate dynamics of celestial mechanics, or the so-called three-body problem in space. Understanding how three objects, like Pluto, Neptune, and the Sun, interact gravitationally is key to this scenario. It's like trying to predict where these objects will be based on where they started and how they influence one another. The stability of all planetary orbits is ensured by the concept of non-concurrent libration. In the case of Pluto and Neptune, this means that whenever Pluto crosses Neptune's orbit, the two bodies are always positioned at least 90 degrees apart. This spatial separation prevents a collision between them. Another contributing factor is orbital precession, which refers to the slow vertical movement of a planet's orbit. For Pluto, this means that when it comes closest to Neptune, or any giant planet, it is positioned well above their orbital plane, providing another layer of defense against potential collisions. An additional factor at play is the VSK wobbling, a concept named after three researchers, V.S., Z.L., and Chi, who studied how celestial bodies interact with one another's gravitational pull. This wobbling effect explains why Pluto's orbit, though seemingly chaotic, remains stable over long periods. The gravitational tugging between Pluto, Neptune, and the Sun influences Pluto's orbit, ensuring it remains relatively smooth despite its irregular shape. The VSK wobbling shows that even in the most unpredictable environments, there are underlying patterns and forces that maintain stability. This three-body problem is crucial to understanding the nature of Pluto's orbit, its relationship with Neptune, and the behavior of distant objects in our solar system. Numerical simulations conducted in the late 1980s revealed that Pluto's orbit, despite the stabilizing forces at play, is actually quite erratic. Small deviations in its initial conditions could lead to significant differences in its path over centuries. Nevertheless, these simulations also showed that Pluto's orbit maintains stability over incredibly long time scales, such as millions or even billions of years. To fully grasp the dynamics between Pluto and Neptune, it is important to consider the gravitational influence of the giant outer planets like Neptune, Jupiter, and Saturn. Neptune's influence is significant, as it governs Pluto's orbit in a special resonance. For every 2 orbits that Pluto completes around the Sun, Neptune completes 3. This offering insights into the forces that govern our cosmic neighborhood. A cosmic collision, fact or fiction? The idea of a Pluto-Neptune collision has ignited debate within the scientific community. While existing orbital mechanics suggest such an event is highly unlikely, the ever-changing nature of celestial bodies means that even the slightest disturbance could alter Pluto's fate. Some astrophysicists argue that an external force, such as an unknown massive object lurking in the far reaches of the Kuiper Belt, could disrupt Pluto's stable orbit. If this hypothetical object, sometimes referred to as Planet 9, exerts enough gravitational influence, it could push Pluto onto an unpredictable path, increasing the likelihood of an eventual encounter with Neptune. But what would actually happen if such a collision occurred? The aftermath of a celestial impact. If Pluto were to collide with Neptune, the consequences would be catastrophic, not just for these two planets but potentially for the entire solar system. 1. Destruction of Pluto. Due to Neptune's immense mass, approximately 17 times that of Earth, Pluto would be utterly shattered upon impact. The icy dwarf planet would disintegrate, sending debris scattering across the outer solar system. Some of these fragments could fall into Neptune's atmosphere, potentially creating luminous fireballs visible from Earth. 2. Creation of a new ring system. The remnants of Pluto could form a new, massive ring around Neptune. While Neptune already has faint rings, the debris from the impact could result in a more prominent and chaotic ring system, much like Saturn's. This could reshape the way we understand planetary rings and their formation in other parts of the universe. 3. Potential for a chain reaction. The force of the collision might trigger secondary effects. The ejected debris could collide with other objects in the Kuiper Belt, sending rogue asteroids and comets hurtling toward the inner solar system. While most would burn up in the Sun's gravitational pull, some might be redirected toward Earth or Mars, increasing the risk of a planetary impact. 4. Changes in Neptune's orbit. Although Neptune is significantly larger, the loss of Pluto could still have subtle effects on its motion. The redistribution of mass in the outer solar system could cause tiny shifts in Neptune's orbit, affecting its gravitational influence on other bodies like Uranus and the dwarf planet Eris. Over millions of years, this could slowly alter the architecture of the solar system. Could Earth be affected? While an event in the outer solar system might seem distant and irrelevant to Earth, such a collision could have unexpected repercussions. A destabilized Kuiper Belt could lead to an increase in cometary activity, sending a higher number of icy bodies toward the inner solar system. Some of these objects, known as long-period comets, could become potential Earth-crossing hazards. Astronomers would closely monitor the debris field from the Pluto-Neptune collision to determine whether any fragments pose a threat to our planet. While the chances of Earth being directly impacted are slim, the event would still provide scientists with valuable data about planetary collisions and their role in shaping the solar system. What if Pluto survives? An alternate scenario suggests that rather than a direct impact, Pluto could experience a near miss with Neptune, leading to an extreme gravitational slingshot effect. This could send Pluto careening toward a completely new orbit, either deeper into the Kuiper Belt or even out of the solar system entirely. If expelled, Pluto could become an interstellar wanderer, drifting into the void of space and severing its ties with our Sun forever. Such an event would make Pluto the first known planet-like body to be ejected from our solar system, raising fascinating questions about the existence of rogue planets, celestial objects that travel between stars without a home. If Pluto were to encounter another star system in the distant future, it could even be captured by a foreign sun, becoming part of a new planetary family billions of years from now. A glimpse into the future. While the probability of a Pluto-Neptune collision remains low, the study of their orbital relationship provides a critical window into the delicate balance of the solar system. As astronomers refine their models and gather more observational data, we may uncover new insights into how planets interact, evolve, and sometimes even face destruction. For now, Pluto remains locked in its stable dance with Neptune, a testament to the intricate and often surprising mechanics of the cosmos. But as history has shown, the universe is full of unexpected events. Whether through a cataclysmic collision or a gentle shift in trajectory, Pluto's story is far from over. Perhaps one day, a new discovery will change our understanding once again, proving that in space, nothing is ever truly predictable. The unexpected twist, a new discovery. As astronomers continued to monitor Pluto's orbit with increasing precision, a startling discovery emerged, one that could change everything we thought we knew about the outer solar system. While running high-resolution simulations of Pluto and Neptune's gravitational interactions, a team of astrophysicists at the International Space Observatory detected a subtle yet persistent anomaly in Pluto's motion. It wasn't just Pluto that was shifting. Neptune itself was being pulled ever so slightly off course. This deflection couldn't be explained by the known gravitational forces of the solar system. Something else was at play. A hidden giant. The anomaly reignited the long-standing hypothesis of Planet 9, a massive, undiscovered planet lurking in the farthest reaches of the solar system. The idea of a hidden world beyond Neptune had been proposed decades ago, but no concrete evidence had ever surfaced. Until now. As researchers pored over the data, they realized that Pluto and Neptune weren't just interacting with each other, they were responding to the gravitational pull of a much larger, unseen object. Calculations suggested that this mystery planet was at least 10 times the mass of Earth and resided somewhere in the outer Kuiper Belt or beyond, in an orbit so distant that it took thousands of years to complete one revolution around the Sun. If true, this meant Pluto wasn't on a collision course with Neptune after all. Instead, both celestial bodies were being subtly redirected by this hidden force. A new threat emerges. Excitement quickly turned to concern. If this Planet 9 was truly out there, its gravitational influence might be more profound than initially thought. Simulations showed that as it moved along its elliptical orbit, it could periodically disrupt the Kuiper Belt, sending waves of icy bodies tumbling toward the inner solar system. Astronomers realized that these disturbances could trigger a new era of cometary bombardment, where massive chunks of ice and rock, some the size of small moons, could be nudged toward Earth. The last time such an event occurred, over 65 million years ago, it wiped out the dinosaurs. Now, humanity faced an unsettling possibility. Was Planet 9 setting the stage for another extinction-level impact? The race to find Planet 9. Governments and space agencies across the world scrambled to confirm the existence of this rogue planet. The James Webb Space Telescope, JWST, was redirected toward the outer solar system, scanning the depths of space in search of this elusive world. Meanwhile, theoretical physicists debated its origins. Some believed it had formed within our solar system and had simply remained hidden due to its vast distance. Others suggested something even more radical. Planet 9 wasn't from our solar system at all. What if it was an interstellar wanderer, a rogue planet that had been captured by the Sun's gravity millions of years ago? A glimpse of the unknown. After months of searching, astronomers finally detected an unusual infrared signature. It was faint, barely distinguishable from background radiation, but it was there. Planet 9 was real. The data confirmed its colossal size, its icy atmosphere, and its staggering distance, nearly $600 from the Sun, 600 times the distance between Earth and the Sun. But there was something else that sent shockwaves through the scientific community. Planet 9 wasn't just moving. It was accelerating. Some force, was pulling it inward, ever so slightly. The implications were staggering. Was this a natural orbital fluctuation? Or was an unknown cosmic force at play? The countdown begins. If Planet 9's trajectory was truly shifting, the consequences could be catastrophic. A closer pass to the inner solar system could disrupt the orbits of Neptune, Uranus, and even Saturn, potentially sending Pluto spiraling into an unpredictable path. Worst of all, if Planet 9 veered too close to the Sun, it could trigger a gravitational cascade, a chain reaction that could destabilize the asteroid belt and send untold numbers of space rocks toward Earth. The countdown had begun. Scientists estimated that within a few thousand years, Planet 9 could reshape the solar system as we knew it. But the real question remained. Was there anything humanity could do to stop it? To be continued.